This is the video on section 6.5, which talks about properties of determinants. Now, the following properties do help simplify things when you have larger determinants, and they help make things move along a lot faster if you can recognize certain properties of these determinants. The first property that we're going to look at is that if every element in a row or column of a determinant is 0, then the value of the determinant is 0. And we noticed this in the last section where we had that whole middle row that was zeros. So in that case, anytime you see that row of zeros, then you know your determinant is 0. If you see a column of zeros, then your determinant is 0. And again, if you think about this as being a 3 by 3 matrix, if you repeat that, each one of the diagonals is going to go through a 0 term, and that's why these end up being 0. Second property, if two rows or two columns of a determinant are identical, the value of their determinant is 0. So if you notice here, you've got 3, this should be a -9, 0, 3, -9, 0. And in this case, we did an example like this at the end of 6.4. If you remember, we had two columns that were exactly the same, and in that case we ended up with a determinant of 0. We're going to have the same thing here. If any two rows or two columns of a determinant are interchanged, only the sign of the value of the determinant is changed. If, for instance, we look at this first determinant, if we wanted to switch the first and the second row, we would just pull a negative out front of the determinant, and we would write the second row up top and the first row next, and then we would keep the third row where it was, and all this would do is change the sign. So this was if we switched two rows. If we switched two columns, for instance, we can again pull that negative out front, keep the first column the same, and then switch these other two. So the middle column becomes 9, 30, 67, and the last column becomes -23, 6, 19. Again, all we've done is change the sign of the determinant. This next one's a little bit more involved, but not too bad. If every element in a row or column is multiplied by the same number k, the value of the determinant is then multiplied by k. Sometimes this is helpful if we want numbers to be smaller. For instance, if we look at this row in the middle here, we've got rather big numbers. If we wanted to factor out a common factor of 9, we can bring that out front. We leave the first row alone. We factored out that 9, so we end up with a 5, a 1, and a 3, and we leave the last row the same. Likewise, we could bring in a number if we had it outside the determinant, and this could become, for instance, if we went to row 1, this would be 5, -15, 6, and then the other two rows would stay the same. Finally, property 5. If every element of a row or column is multiplied by the same real number, and if the resulting products are added to another row or another column, then the determinant remains the same. And essentially, when you want to use this is when you want to make a certain term 0, so that you can make your determinant easier to work with if you have more zeros involved. So, for instance, if I wanted to make this -2 into a 0, I would take row 3, I would multiply it by 2, and I would add it to row 1, and that would replace row 1. So if I did that, I would do 2 times 5 is 10, plus 3 is going to be 13. That 2 times 1 is 2, minus 2 is 0, and that 2 times -1 plus 6 is going to be 4. The other rows I would leave alone. And now I've got multiple zeros in here, which is going to make my determinant easier to solve. So this concludes the video for 6.5. Please go online now and complete your homework for this section.